Hi everyone. As informed earlier, my presentation it will be about this AI with brine mining. And when Sean contacted me previously to talk about this topic, he told me that this is a very informal workshop with with small number of people. So and I can just talk whatever I want to talk. So I prepared the presentation with this approach. And when I saw the presentations from two previous speakers, and I realized that he cheated me. Anyway, so the topic, the contents of my presentation will be really informative, and this is not technical. So I just want to talk about some concept and ideas, and I just also wanted to have some feedbacks from my presentation because we have launched a project and we want to hear many ideas from many other peoples. Anyway, so my presentation will start with some background and motivations for AI for desalination and brine mining. And then I will also talk about the reason why we have to consider this. So why we need AI for brine mining. And then I will briefly introduce my project, which is called Promise. And many people will wonder why it is called Promise, and I will explain the origin of the name. And then these are really the preliminary cases, but I will just present the 3 case studies from a Promise project to show how we can combine AI with brine mining. And then I will also talk about the challenges. So desalination technology is evolving from the first generation technology of distillation to second generation of reverse osmosis. And many people have tried new technologies like MD, PRO, the FO with reverse osmosis. And I can call it as the third generation technology. And now we are in the age of fourth generations. And many people will agree that fourth generation desalination technologies can have 2 directions. The first one is the distal desalination, and the second one is brine mining. And distal desalination is motivated by the needs of low energy consumption and for not only the main desalination process, but also for the brine mining. And as for the brine mining, this comes from the needs for the environmental concern by brine, and also the needs to for the circular economy, something like this. And so when we talk about the AI for desalination, there are many researches in the academia as well as in industrial sectors. And the reason why many people are considering AI in academia is to, for example, to predict fouling and to perform some preventive maintenance, and also there are some needs for predicting the performances. And there are many reasons why we have to apply AI for desalination itself. And so AI models, many AI models have been applied for desalination. Some of the models are for the predictions, and some other things are for the classifications, and there are also some hybrid the algorithms. So ANN and GP and some other algorithms have been applied for desalination sectors. So as Professor Sean mentioned, there are a lot of papers regarding the AI for in these days. And also there are some clear trend of applying AI for desalination in industrial sectors. And there are several companies who are actually actively working on the application of AI. But in my opinion, these are rather preliminary. So they have just started this kind of approaches. So they have presented some concept, but they don't have a clear result yet. So we can say that we are still just in the early stage of applying AI for desalination in industrial sectors. Now we are talking about the reason why we need AI for brine mining, and we can just list some of the reasons why we have to consider, and those are all the demands for developing technologies. So these are the reason why we needed to develop new technologies by combining AI with these brine minings. First of all, if you consider the brine mining problems, it's high-dimensional optimization problems because there are many conflicting outputs. For example, if you wanted to recover more resources, we needed to concentrate more, and we will spend more energy. And not just energy, there are all other factors affecting the whole overall performance. So in order to solve this kind of complicated problems, we needed to use AI for the process optimization, and this is one of the reasons why we consider this. The second one, brine mining requires the use of chemistry, and this is very complex because we are talking about more than 10 salts recovered from brines, and this non-linear chemistry requires the use of AI models rather than just some conventional, traditional models, and this is another reason. And AI actually can learn some plant-specific corrections, so we can just have more accurate predictions by using AI. And real-time control is also very important because many things will change with time, especially in brine mining processes, because brine mining processes is a combination of brine concentration with mineral extraction, and the efficiency will change significantly when the environmental factors change. So that's why real-time control is required, and that also requires the use of AI. And another situation that we have to consider is the optimization needs for the product quality and the product cost, because when we recover minerals from brine, the actual cost change with time due to the situation in the market. And at the same time, this process efficiency and other factors will change, and they will all make this problem very complicated. And again, we needed to use AI for solving this kind of problems. And in the future, definitely we needed to combine this brine mining with renewable energy sources, because in most cases, brine mining is energy intensive, and the use of renewable energy will actually create another complex situations, and again, AI will require for this kind of optimization. And the last thing is the lack of the experts in this field, because not many people can deal with the brine mining process, and in order to overcome this kind of situation, the system should be very easy, and that can actually help the operators to operate this kind of complicated processes. And these are the reasons why we start considering AI for brine mining. At this moment, I want to introduce the new research project supported by Korean government, which is called Promise, and this actually means the pioneering research on membrane-based desalination inducing sustainability and energy efficiency. So the name actually comes with this description of this project. Promise means the promise, so we want to become a promise for the bright future of the desalination technology. In fact, this project has started this year, and this will last for the next 5 years, and this is a multi-million-dollar project. So more than $30 million will be investigated for this project for practical implementation of digital desalination and brine mining. So this project consists of 3 work packages. The first work package is about the digital desalination, and the second one is the brine mining, and the third one is the demonstration. So we don't want to just develop technology. Instead, we just wanted to demonstrate the technology so that we can be ready for the market for commercialization of these new technologies. So the idea is very simple. So we will have desalination process, and we will develop new processes for brine mining, and the desalination process and brine mining process will be integrated and optimized by using digital technologies, including AI. And finally, we will build a demonstration plant with a capacity of 1,000 cubic meters per day. And from that, we will be ready for commercialization. As for the first work package, and we focus on 3 things. The virtual design of the process, which means that we can reduce the time required for process optimization, and we can find the best condition for the process performance. And also, we will develop the AI-assisted operation technologies, so we can predict foulings and energy efficiencies, and so that we can support the people who actually works in this plant. And the final one is about the maintenance. So by detecting the fault of pump and ELD and some other devices, we can actually perform the predictive maintenance. So we have not developed anything yet, but after 3 or 4 years, we will have a prototype of the digital desalination platform. And we actually create an image for the future systems, just for your understanding. So this is not the real screenshot from the software. This will be the screenshot of the future products. But anyway, the reason why I'm showing you here is since we have 3 components in this digital desalination platform. The first one is about the virtual design, consisting of this digital twin synchronized with the real plants and the energy minimization modules, as well as the virtual design. So we can just change all the parameters in the digital twin so that we can find the condition for minimizing the energy consumption. The second one is the operation and the AI-assisted operations. So we will develop several AI models for fouling prediction, screening, optimization, and pre-treatment optimization. And then we will develop real-time decision support system so that people can also get some information from these AI models. And we also will develop the LLM-based interface. So large language model will be used so that the people can just communicate with the actual desalination systems through the interface, which is very similar to ChatGPT or some other generative AI systems. And as for the final, the maintenance, we'll develop some fault diagnosis and prediction modules, and also we will use AL and VR for remote maintenance of the systems. So all these things will be developed for the next 5 years. And I just want to talk about some of the examples, and okay, I'll do that. First of all, let's just think about the reason why we need AI for brine mining. And AI has 4 steps. The first step is the things that, so when people wanted to do things faster, they need AI. So that's the first step, so that this AI model can do the things faster than the people can do. And the second step is that the stage that this AI can do the things easier than the people can actually do that. And the third step is that the advanced step. So in this case, the people can do better than actually people. The AI model can do better than the people can do. And the last step will be the stage of autonomous operation. In those cases, there is no need to have human operators, but this is the ultimate step, and we just wanted to stick to the previous 3 stages. As for the first case, so the examples of AI for pastel design. So we are developing the virtual the design interface and the systems. So this system is not only for the desalination system, but also the brine mining process. So basically the idea is there are some mathematical models as well as the AI-based models for the process design. And the conventional way of using this technique is that the people actually design for specific conditions, and they get the result, and they repeat until they can have some successful, some reasonable result. And instead of doing this, we just wanted to make an system that this optimization can be done automatically using the computer systems, so that we can reduce a significant amount of time when we consider millions of different combinations of operating these parameters. So we are actually doing currently for the reverse osmosis system to find the lowest energy consumption condition, and we are also working on these brine mining processes. The second case is for AI for easier operation, and as mentioned earlier, we are developing this interface based on large language model. In this case, we are aiming at the development of domain-specific large language model, and combined with RAG, real-time information feedbacks. So currently we have some prototype, but in the future we will actually have interface system actually better than ChatGPT. So you can imagine like we are developing a specified ChatGPT just for desalination and brine mining. So we are actually developing this technology, and with the limited time, I cannot explain everything, but you can just understand that we are just developing this kind of system one by one, and this system will appear probably within 2 or 3 years. The third one, we also try to use AI for a better maintenance. So in this case, we are just developing AI models for the brine mining process optimization, And in this example, we are focusing on the recovery of calcium and magnesiums by mineralization, carbon mineralization. So again, this requires a lot of non-linear chemistry as well as complicated this optimization problems. So we are developing several AI models, and we have some complicated techniques to predict the performance. And with this information, we'll eventually develop these final systems. So since we have just started this project, so the result is not the final, and we are just going for these directions. So again, feel free to let me know if you have any ideas and suggestions for this kind of approaches. The last one, technical challenges. As you know that AI is not the solution for everything. Instead, it has a lot of limitations. So AI is a black box model, so we actually don't know what's actually going on inside this model. And model drift significantly, and its data is actually limited. So, and we wanted to have some abnormal data, but most plant data is the normal data. So there's a significant bias of the data for training AI models for desalination and brine mining. And there are some skill gaps that should be overcome. And the possible solutions that we can suggest is, first of all, we needed to go for the explainable AI rather than conventional black box AI. This will actually reduce the risk of the AI artifact, and we can use monitoring MLOP kind of approaches to reduce model drift, and we can create some generative data for overcoming this data bias. So there are several techniques suggested, and by doing this, we think that we can significantly overcome the challenges related to the AI applications, to desalination and brine mining. With that, thank you very much for your attention. Thank you.
So, any burning question before we start our panel discussion to Professor Sangho Lee? No?